Hello, everyone. So we're gonna start the second day. Thanks a lot for coming in person. Today is getting a little bit colder, and but hopefully after tonight we get all warmed up with some MLOps content. Before I start, is there any question from the previous session? I know that there were so many hours was spent with the amazing TAs we have. There were so many questions that were resolved, so many questions were sent directly to me or within the chat in the Slack. But if there's any question which is outstanding from the first session, please ask them now. Otherwise, we can just start with the content. Any question in the room? Any question? Yes, please.
So the question, when we were creating pipeline in Azure, in dev.azure. So we removed there was a template and we removed the second stage, which was publishing results. Could you briefly explain what this is for and when it is used?
Yeah, in software engineering, there's a concept called build. So historically, in most of the programming languages like Java, Python, Java, C#, and some of these compiler-based software languages, they basically have the code, and that code cannot be directly executed on a machine. They have to first be built into a binary format or executable binary object, which is closer to the language of the machine. So within the release section or the build section, which happens which we removed, what it generally happens is that in the first part, it generates the tests, make sure all of the code runs friendly, and then it produces the executable object. Then that will be shared within something called artifacts within Azure DevOps. In Python world, sometimes you would like to generate something called wheels from your Python application through a package, for instance. All of the packages you find within pip install, they're wheeled and they're provided there. So you can also generate wheel files from your Python application. But in this setting, that's not the focus. Because of that, we remove that and we will not use it at all. Yeah, so to answer your question.
Yeah, and second quick question about GitHub. So as a part of my assignment, I went onto your GitHub and forked your repository, and then I always see that my repository was forked from yours, and when I want to merge branches, I have this confusing choice of many branches, both located on my fork and on your origin. So can I make GitHub forget that I got it from you?
So you can basically so the reason that fork gives you the option to merge to my branch, it looks like an open source. First, if you want to contribute any open source project, first you have to fork it. You cannot work directly on that repository. So when you make the modification, you probably want to merge it back to the original.
Okay.
So that's the reason it keeps the lineage, but of course you can remove that. And you can also start from scratch. You can clone from myself and then change the upstream repository to push it somewhere else, basically. Yeah, no problem. Any other question? We're good to start? Awesome. Also, thanks a lot, Amir and Ace. They actually bought this for me so I can stand and talk instead of sitting. So I feel I have more energy than last week. I was about to sleep. It was getting super cozy. So first, I want to thank our amazing TAs. First, we forgot to introduce them. These are four amazing TAs that spend a lot of time with you during the TA hours. This is the list of the TAs ordered alphabetically: Ali, Jack, Werner, and Willie. Two of them focus on GCP and the other two focus on AWS. Please reach out to them if you have any questions for your capstone projects. If it is Azure, Ali also focuses on that. Also, definitely you can ask the rest of the TAs. If you have any Azure question, also you can directly reach out to me if you have any question for your capstone project. So today we're going to focus on reproducible experiments. So the thing that you left from last week we're going to discuss today. Then we're going to focus on how we can create a machine learning pipeline. So last week we built a build pipeline from DevOps CI concept. So today we want to build a machine learning pipeline. So many of you were waiting for getting to the training parts and doing some cool machine learning parts. So this is today, we're gonna focus on that a lot. And finally, we're gonna integrate that machine learning pipeline into our CI or pull request pipeline and show you how you can basically how that makes sense throughout your MLOps flow. But before I start, I want to give you the overall picture of what MLOps flow looks like. So I start from here. This is where most of the data scientists sit. So whenever you actually start working on any kind of experiments and you write your code, right? Definitely you have to use any coding platform. 99%, I'm exaggerating, but majority use Python or R. Whenever you basically write your code, you would need some sort of source controller, as we focused a lot from last week, right? So you push your changes to the source controller. And by the way, you have all of the slides provided in a shared repo, in a shared folder within Google Docs. I posted that within the Everyone Slack channel, the link to that folder. Please go ahead and download that. So you will have the slides, you can go through that. And also there are some links to some external GitHub repositories as we get to them. So we get to those. So yeah, so we push it to the source control, like GitHub, for instance, as we discussed last week. And when anything, an action or an event happens here, you can define a trigger, like the same thing as they defined last week, right? We defined a pull request trigger. That pull request trigger can be approved automatically or manually by a peer reviewer, right? So before this or after this, you can actually kick off a build pipeline for pull request or continuous integration. Again, going back, the pull request happened before the merge, and CI happens after the merge, right? So this will check whether your code actually is healthy, it works fine. In most of the software engineering, basically runs the entire application to make sure all of the tests are successful, there's no syntax error, there's no compilation error, and the actual final binary is built so they can basically do something with it, right? In machine learning context, that application, which is executed on the build pipeline, will create a machine learning pipeline. So this application is actually executed on a very typical hardware, like a local computer or development environment, which doesn't have really a very crazy spec. It's super lightweight, and it can basically execute a Python script. So within that Python script, you want to instruct the Azure ML to create a machine learning pipeline. And that machine learning pipeline can consist of a couple of steps: data preparation, training and validation, and registration. This pipeline will be executed on a dedicated hardware. So that can be a cluster of nodes. All of them have like a couple of GPUs, or a single VM again, right? So you can define the type of hardware that you want to execute this pipeline on. So again, the result of this build pipeline is a machine learning pipeline. We'll go through that today. And the machine learning pipeline will generate a model. So the last step of a machine learning pipeline is mostly validating whether its model is improving the existing model into production or not. If it is improving, it will push it to a model registry as a new model is registered. So now, once a new model is introduced, again, you want to trigger another pipeline through Azure DevOps. So Azure DevOps is talking or listening to the model registry, right? And it is basically sensitive about if a new model is saved within the model registry or not. So as a new model lands in the model registry, you want to kick off another pipeline which will give that machine learning model and deploy it in a target hardware or cluster based on how you define it. And then that can be a single, again, node web service, or it can be a cluster on Kubernetes cluster. You can define it. We will focus on the third day. And then once it is deployed here, you want to basically start listening about all of the things that are happening in the wild and keep collecting the telemetries. And based on these telemetries, you want to make some data-driven decisions. So you would basically go back again to this machine learning pipeline if you want to retrain or basically coming to a new model. There's also another stream here, which is not the focus of our workshop, but that's the data engineering pipeline. So again, you have the capability to trigger your machine learning pipeline or training a new model as a new data lands your storage. That's also, so you want to train a new model as a new data comes in, based on some kind of criteria if you want to define, or you want to train a model based on new code comes in, right? So you want to basically always be on top of that and being able to automate the whole process instead of every time you change the code, you deploy it somewhere, you train a new model, you basically want to automate the whole process. There are certain best practices here that you can basically add some manual approver to check or do some code reviews or just make sure everything is fine. And also at this stage, before everything gets deployed to the production, so again, you want to manually or automatically check it instead of having full automation. But the most important part is basically being able to create new machine learning pipelines based on new training code as it hits your source repository. So we'll focus on how building that machine learning pipeline and how we can basically integrate that to our CI/CD pipeline. Any question? If there's any question beyond this, please, we can focus later on, but if there's any question before this, yes, please. Yeah.
Go ahead.
Okay. You asked.
Go ahead.
Okay.
Do you still do a manual approval process for if there's any new data that comes in, or is it just for the code review?
So you can also have added manual process. I don't want to complicate that part because that's not the focus, but absolutely you can for sure add some manual processes there. Yeah. You can trigger something. That type trigger can start like getting reviewed and accepted by another person. You can basically design a workflow. Yeah.
Okay.
Yeah. Two questions. So first, when I create a pull request, under what circumstances I accept it manually, and when I need to check it out, because I understood that this is the purpose of the pipeline to check it out.
So the most of the teams, majority of the teams, use a manual process because tests can go to some so far. They cannot basically do everything. If you're completely confident about all of the tests you've built, you can basically remove this and make it completely automated. But if the tests are not completely built and not 100% confident about the tests, which most of the cases is not, so you still need to do some level of manual approval, but at least have someone to be responsible for that final yes, so you can basically point the finger to. Mostly teams have manual approval. So again, to rephrase, if you're very confident about your test, you're sure that every aspects are basically tested, and you're confident about all of the code developed by your software engineer or data scientist, so you can basically let that happen automatically. But again, it really depends on the severity and criticality and sensitivity of the application, how sensitive it is, and how you're going to basically make the whole process automated. Yes, please.
Could you shed light on this item in the top left, experiment tracking?
Yes,
so
this is the part which we're going to focus today.
Okay, is it done locally or are any cloud services used for that?
So yeah, we're going to use Azure. Azure is the only cloud provider which does have automated experiment tracking, but there's MLflow, which I referred to in the deck, which is open source. You can basically host it anywhere, cloud or anywhere.
And Azure ML model registry is storage for some more mature models. Not something I'm playing with, right?
It can be anything you play with. So you can have multiple types of workspaces. One can be development area, which you basically try out and basically play around. It can be one workspace which basically has the production environment. Everything there is very serious. So you can play around the development environment and basically deploy in a serious place. Yeah. it all goes to the processes, that how your team wants to use all of these technologies and basically build a process around them. Yeah. Also, you don't have access to the Slack channel. If there's any question from the Slack, thank you very much.
Yeah. Awesome. So there are a couple of best practices from the previous session that we're going to again go through again. So first of all, on the CI pipelines or like pull request pipelines. First of all, do not work directly on the master branch. Definitely have some type of secondary branches like dev or release. I will share with you a type of a branching strategy today. But again, use whatever you want, but do not use only one branch. Beat some level of testing or some test scenarios at the pull request and the CI. Of course, pull requests give you a lot of flexibility before the code getting merged, so you will have some power to be able to reject or accept the pull request or the changes. Come with a branching strategy which makes sense to your team, based on the maturity of the team, based on the sensitivity of the project. These will change that strategy drastically. So now we're going to discuss about the a tool that we're going to focus today and within the workshop. Of course, there's a SageMaker and the AI Hub on the Google if you have different focus, but like some of the parts of these tools are very similar to each other. Some of them do not overlap, so I'm going to touch on them. So the ML services basically focus on the full cycle from the data preparation, the coding, the experimentation, deployment, registry, and the model registry, model containerization, and also the deployment part. So we'll go through them one by one to show you basically how you can use it and then get it as a framework. If you have a different platform, you can first ask for it or search for it if you know the concept, then, or if it is not available, maybe use the Azure or some open source tools to basically fill the gap. So the entire story about the ML service is that when you create a service, you need to search for Azure Machine Learning Service Workspace. So when you deploy that workspace, you basically are given 7 different components: the model, experimentations or experiments, the pipelines, compute, image, deployment, and the data stores. We're going to focus on each and how you can basically use them to build your MLOps story. But it is important to have this picture in mind, that how these are connected to each other. This is basically the taxonomy of the ML workspace, and it shows you that how things are connected to each other. We go through them to that makes sense. This is a little bit like too crowded. But something important is that whenever you create that ML service, behind the scene, there are 4 main services are created. One is a container registry, which keeps all of your Docker images. If you want to create them, it will register them, similar to Docker Hub, but it is on the cloud for yourself. It creates a storage account behind the scene. As a default storage account, you can keep it for development purposes. The app inside, where basically it keeps track of everything which is happening within your application for your logging and monitoring. And finally, Key Vault. The Key Vault is a way to securely save your the secrets like credentials, password, and etc. within the environment, so you don't hard code that within your application. We will use some of them throughout the workshop. But first, let's focus on the experiment's reproducibility. So we have discussed that a lot before, that the data and the ML code will merge together or marry together to produce a model. And the way we do it is based on some trials, right? So every time we have a hypothesis that we assume this model works, we're going to try it out. We're going to test and evaluate the results. If it failed, we're going to start again, right? So that every time we go through that, there will be different code, probably different data, some different features, and some different hyperparameters. And also, for different codes and different methods, you may use a GPU or CPU or cluster or single node based on the size of the data and the problem you want to solve. Again, that's another part which requires to be reproducible and be versioned. So in order to track your experiments, there is a service, there is a section within the Azure ML if you create, which is called experiments. So the experiments is a logical equivalence for the hypothesis. So for instance, I want to prove out that a random forest works well with my data, right? So that is a hypothesis you want to try out, and every time you want to basically change the parameters, come up with different parameters, with different data set, and then build a model. If it's not performing well, you're going to change that, run it again to see how it's working. Basically, every run is a trial to test that hypothesis, or the trial of sadness. You go, it fails, unhappy, go back again, go back again. That's basically the tedious part of most of our data science workload. And you want to basically keep track of all of these logs. And the logs are kept into 4 main categories. I don't want to spend time on explaining them here. I want to show you how actually it works within the lab. But then every of these experiments, again, every of these runs can be executed completely independently. So in one run, you probably use one algorithm. The other one, you can use completely different algorithm. In one run, you want to save some data or some models or some log files. In the second run, can be completely different. Like these are like dictionary objects that it can be completely different from each other. And you want to basically run it on different types of environment, run it on your local computer, run it in cloud, different types of compute environments again, on like single node, a cluster of nodes, or Databricks, or HDNSI, or Spark workloads. And also, your experiment will potentially, may basically produce a model. Not every experiment produces a model. Like if you're exploring the data, you may not produce a model, but if you're training a model, you may produce a model. You want to save it there, or you may consume a model which is already trained. Like you want to use some pre-trained model to do some transfer learning. It is already registered before. You want to pick that and then use it within your training code. Or you have some data sets, you want to save some data sets, intermediate data sets, or you want to fetch some data sets. So basically, that data set also can be some way of communicating with the experimentation, and you want to basically being able to keep track of that.